All right, we've already spent some time talking about Martians and the sort of science fiction aspects of life on Mars. We've also talked quite a bit about Mars exploration, but we haven't yet really taken a critical scientific look at what are the real possibilities of life on Mars in light of everything we know about the planet, and in turn, sort of life of elsewhere in the universe. We'll get to that question of life in the universe in more depth later, but Mars is a great test bed for us now. So it was believed for a long time that life really required some basic things in order to exist. Like you need to have water, it needs to be liquid, the temperatures need to be comfortable, right? So not too hot, not too cold, like maybe, roughly, life probably can't survive if it's above 150 degrees or something like that. All these constraints, right? But in the past few decades, biologists have been discovering life in very unexpected places. Places where it was believed no living thing could really exist. But it's important for us to recognize that when we talk about life, exactly what we're talking about. Remember, life is more than just like dogs and cats and birds and people, right? Life includes things like mushrooms and grass and bacteria and planaria, whatever those are, right? So we have to think about even single-celled life, even the simplest life imaginable is still life. And we remember that it's important for us to consider that we have not yet seen any real strong evidence that even single-celled life, any form of the simplest kind of life, exists anywhere else in the universe, including Mars. So these discoveries of really robust life forms here on Earth lead us to wonder whether it may really be possible that life could live in places that we thought previously impossible. These living creatures have been given the name extremophiles. Extremophiles because they seem to not only be able to survive, but to thrive in environments that would be deadly to other organisms. So just as a few examples. One is bacteria that lives in these hot springs that are scalding temperatures, extremely acidic, places where you would expect life not to be able to survive. In a similar way, biologists have discovered life at these hot vents at the bottom of the ocean, right? So for many, I gotta take a phone call. Excuse me. I have a student calling. I'll be right back. Sorry about that. So the amazing thing, right, is that scientists for a long time thought that really all life fundamentally depended on energy from the sun. All right? That would be one of the criterion for life. You have to have energy from the sun. So, right, because energy from the sun is what makes plants grow, and then the plants feed the animals, and yada, yada, yada. Okay? Everything depends ultimately on the energy from the sun. Well, what this discovery showed is way down here. It doesn't look like it in this picture, but down at the bottom of the ocean, no sunlight reaches there. And instead, it's heat coming from the interior of the Earth, right? So there's magma and lava and all this stuff that's being heated through radioactive processes. And that heat energy is what's actually fueling the life that's found down here, these extremophiles. So what was so shocking about this is it was ultimately like an alternate source of the energy to support life. And what door that opened was that perhaps then you could envision living creatures and bacteria and whatever else that might live beneath the ground, right? Or maybe locked deep inside the ice somewhere. And in fact, since these original discoveries, it seems scientists find life everywhere they look on Earth. Whether they're drilling in cores deep in the rocks, or through ice, or in the most extreme of locations. One of my favorite extremophiles is called the water bear. And this is a microscopic creature, and just looking at it is like just incredible. I mean, it just looks like an alien, doesn't it? It's this tiny, tiny little thing. The reason it's so extreme, excuse me, is that it can be completely dried out. Like you can dry it entirely for like a decade, like 10 years, and then you add some drops of water to it and it kind of reanimates and comes back to life. Right? So these things can even survive traveling through empty space. They've been exposed to empty space to see if they survive, and they do. So these are truly extremophiles. Now, what does this have to do? This is all life on Earth. So what does this have to do with Mars? Well, if we're learning about life on Earth and we're finding that life can exist in places we thought previously impossible, it causes us to question some of those assumptions we made when we saw like the images from Mariner and we're like, this is a dead planet. Well, we're like, well, maybe it's not so dead. Maybe there are living things. So one of the most dramatic examples of this was in a particular meteorite from Mars. Now, I know, think about this a second. Let that sink in. A meteorite from Mars. So we find meteorites on Earth, right? Like rocks that fell from space. And what's amazing is that some of those rocks actually originated on other planets, including Mars. So by analyzing the material of the rock, you can actually tell where it came from and link it to a different origin, like the moon or Mars. So we have moon rocks and we have Mars rocks that actually came to Earth through natural processes. The way that happens is like an asteroid smacks into Mars a long time ago, blows a bunch of rocks out into space. Those are flying around, and eventually some of those land here on Earth. Well, as scientists were studying one of these rocks called ALH 84001, what they discovered was here's a nice slide, a tubular structure approximately 100 nanometers long, possibly a fossil of a microorganism living on Mars billions of years ago. And so here is a photograph of it. Let's see if we have a nicer picture. It's a little bigger or something. Probably not. It's this tiny little tubular structure, tiny little line. And the thought is, well, maybe this is a fossil of bacteria. So, as is often the case, this is a rather extraordinary claim. This would have been the very first evidence of any life form off the Earth from any other place. And it didn't really hold up to scrutiny. It got a lot of media attention at the time, but didn't really hold up to scrutiny for a few reasons. One is this was a meteorite that was on the Earth, so life forms could have seeped into it because they're everywhere here on Earth. Another is that geologic processes could cause this kind of structure. We saw like the crazy spheres on Mars that are formed through natural geological processes without any life being involved. In the same way, these kind of structures could have arisen through a geologic process that's not tied to any sort of life form. So this was the best example, which is hard to even call it that, of some sort of fossilized evidence of life on another planet. The one other piece of evidence that's worth mentioning, and it gets to an area of astronomy we'll talk about more later called astrobiology, which is how could you detect living things on other planets? I mean, it's one thing to have a rock and dig in it and look for fossils, but how could you look at a planet far, far away or a planet around another star and look for evidence that life might be there? Especially when like our early scientists, you can't really see the surface. All you can do is capture the light. Well, one way to do that is by looking for some of the things that life gives off. When I breathe, I exhale carbon dioxide, right? So that's an indicator of a life form. The trouble is there's a lot of natural processes that also give off carbon dioxide, right? Like volcanoes. So when you see carbon dioxide, you don't like say, wow, there must be a Vandenheuvel living on that planet because I saw carbon dioxide. There's a lot of possible explanations. In a similar way, methane is a potential indicator of living organisms. And we see evidence of methane on Mars. So here's a map, for example, of methane on the red planet, okay, and it changes with the seasons. So you can see here is the methane concentration, how it's distributed on the planet. And this graphic illustrates, more technical than we're going to talk about, ways that methane can be created. So one way is, as you see down here, you could have microorganisms living beneath the surface that are giving off methane, right? And that then could be released through the surface, this outgassing, getting into the tenuous atmosphere of Mars, and that's what we're detecting. The trouble is there are also other natural processes, but they're sort of equally interesting, one of which is a certain type of rock, olivine, mixing with water. So if you have water beneath the surface interacting with this rock, it could also be producing methane gas. All right, so interesting on both sides, but perhaps most interesting would be if this is evidence of life on the red planet. I don't think any scientists would really say that this is that methane on Mars is any sort of indicator of present day life there. Although I think there is a general attitude that, given how much we've learned about extremophiles here on Earth, that it is conceivable that there could be such simple and extreme life forms that exist on Mars as well. Again, we're going to revisit that question of life in the universe in more depth later, but life on Mars, I think it's fair to say, is pretty much a highly unlikely scenario at this point. All right. Well, thank you very much, and I will see you next time.